Now, the same logic applies to P of A intersection B plus P of A intersection B prime should also give us 1. So it means that P of A intersection B prime is equal to 1 minus P of A intersection B. Now, by De Morgan's law, we say that P of A intersection B prime is equal to P of A prime union P of B prime. So it means that somebody can say that find P of A intersection B prime, or oh sorry, this is so wrong. It's supposed to be this. It's supposed to be P of A prime union B prime. Right? Somebody can say find P of A intersection B prime, or find P of A prime union B prime. And it's all the same. It is all the same. Okay. We'll look at another question. If A and B are events such that P of A is equal to 8 over 15 and P of B is equal to 2 over 3 and P of A intersection B is equal to 1 over 5. The question is that, are A and B exhaustive events? Now, what is an exhaustive event? Exhaustive event is the case where P of A union B is equal to 1. Now, we know that P of A union B is equal to P of A plus P of B minus P of A intersection B. Now, 8 over 15 plus 2 over 3 minus 1 over 5 is equal to 1. You can check. And because it's equal to 1, we will say that it is an exhaustive event. Okay. Now let's learn another one, another step. When is two events said to be independent? Independent. Now, two events are said to be independent if the occurrence of one does not affect the occurrence of the other. If the occurrence of one does not affect the occurrence of the other. If Lord is playing football, and Tommy is playing basketball, now these are two events which are occurring at the same time, but the Tommy playing ball will never affect Lord playing football, or Tommy playing basketball will never affect Lord playing football. Now, mathematically, we say that if two events are independent, then when we multiply their probabilities, P of A times P of B, we should get P of A intersection B. This is the definition for independence. Independence. So then we look at an example. The question says that if A and B are such that P of A is equal to 0.3 and P of B is equal to 0.5, we are supposed to find P of A intersection B. You understand? Now remember, he said that if A and B are independent, what does it mean when they are independent? When they are independent, it means that A intersection B is equal to P of A times P of B, which is 0.3 times 0.5, which is equal to 0.15. So A intersection B is equal to 0.15. Right? And the next question is, we are supposed to find P of A union B. And we know P of A union B is what? P of A plus P of B minus P of A intersection B, which is 0.3 plus 0.5 minus 0.15. And this will give us 0.65. I hope it is very clear. In another example, if P of A is equal to 0.4 and P of B is equal to 0.25, and we are saying that A and B are independent. A and B are independent. We are supposed to find I, P of A intersection B. Now, because we know they are independent, this is just equal to P of A times P of B, which is 0.4 times 0.25. Right? And this is going to give us 0.1. 0.1. Now that is A intersection B. Next, we are supposed to find P of I says we are supposed to find P of A prime intersection B prime. Remember, we said that A prime intersection B prime is the same as what? This is the same as, by the Morgan's law, this is the same as P of A union B all prime. Right? Which is also equal to 1 minus P of A union B. So you must first go and find A union B. Once we get A union B, we will subtract from 1 and we are fine. But we know that P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A we say is 0.4 plus P of B is 0.25 minus 0.1. Okay, and this is going to give us 0.6. Is it 5 or 65? It's going to give us 0.55. It's going to give us 0.55. So now clearly we can come back and find P of A union B all prime. What is just 1 minus 0.55, which is going to give me 0.45. You understand? It is very clear. Okay, 0.45. So P of A prime intersection B prime is equal to 0.45. Next, we are supposed to find P of A intersection B prime. That is A only. Right? Now, A intersection B prime is equal to P of A minus P of A intersection B. You understand? P of A minus A intersection. Now, this one, this is it. You can even do a Venn diagram for it. We don't even have to just even bother. We can just do Venn diagram and we can see this thing clearly. If I want to do a Venn diagram, P of A, P of B, here was 0.1, and A 0.4, and this was 0.25. So here we have 0.15, and here we have 0.3, and now here is 0.45, and this should give us 1, junior. So here, A only is 0.3, B only is 0.15. You understand? It is so clear. Okay. Okay. We move on. Next, another question. Now, if A and B are independent, such that P of A is equal to X and P of B is equal to X plus 0.2. X plus 0.2. We are supposed to find the value of X. Okay, and A intersection B, the probability of this is equal to 0.15. We are supposed to find the value of X. Now it's very simple. If two events are independent, then P of A intersection B is equal to P of A times P of B. So here 0.15 is equal to X plus 0.2 multiplying X. And we will solve this, right? You solve this. The solution is in the book. And it's so clear, right? We will solve this and we will get X to be equal to 0.3 or minus 0.5. And you know, probability, we don't deal with minus. Remember, probability is always between 0 and 1. So we'll choose 0.3 as our X, right? And once we found this, then we can now find P of A union B. You understand? The solution is in the book, so I won't waste your time on this, right? If you read the book, you'll be fine. Okay.